This hangout is live. All right, we're waiting for Marco. He's the only one coming tonight. But it's 3 minutes past, so I'm going to start working on this. And if he doesn't show up by the time I get done, well, it's too bad. Okay. Okay, which hypothesis involves equality? Oh, okay, the equal sign. Okay, so the null hypothesis does, because you're saying the status quo is right. So you're saying the null hypothesis equals this. P-value is the probability of obtaining a sample statistic at least extreme is 1. Actually, sorry. Remember the p-value is. Okay, so when computing the p-value, which hypothesis do you assume to be true? The null hypothesis, because that's what we're trying to reject or fail to reject. All right, so which of the following represents the alternative hypothesis for a two-tailed test? That would be the not equal sign. Which of the following represents an alternative hypothesis for a left tail sign? That would equal less than sign. The mean is less than. The right tail, that would be the greater than sign. The mean is greater than whatever. What is the relationship? Which relationship would be in failing to reject the null hypothesis? So if the p-value is going to be greater than a, what is a called again? Level of significance. Okay, so a is level of significance. So if the p-value is greater than the level of significance, usually it's 5%, then you're going to fail to reject it. I'll double check on that. If the p is low, reject the null. So this, so less than would be, oh wait, if the p is low, reject the null, and we're going to fail to reject, so p-value is great. All right, which were the relationship rejecting the null hypothesis? So if the p-value is low, we reject the null hypothesis. Which of the following would be an appropriate alternative hypothesis? So the null hypothesis would be average claims equal $1,500, and they believe it's going to be higher. So it's going to be the average claim is greater than $1,500. Which of the following would be an appropriate null hypothesis? The average claim is equal to 1,500. That's pretty easy. The company selects 40 claims, calculates sample mean of 1,650. Assumes is normal. It is a good example because, or it is a good assumption because the sample size is large because of central limit theorem. What theorem justifies your answer to the previous question? Central limit theorem, like I just said. Which of the following is a test statistic as defined in the lesson? That's going to be Z for the Z-score. This is a long quiz. The historical mean of cells, blah, blah. What is the Z-score associated with this test? Around 3 decimal places. All right, so let's open up an Excel file and see if what we can do. All right, so 0.5, the z-score associated with this test. So we're going to put in the value of $144. The mean of $150. Let's see, standard deviation of $40. And we have a sample of 36. All right. That's going to be 0.900. The p-value, the previous question, well, all we have to do is take 0.9, put it into the probability outlet. The area under that is 184. What inference would you make about the null hypothesis for this problem? Well, we're going to fail to reject the null hypothesis because the p-value is not lower than 5%. Or it's not lower than the A. What is A again? Level of significance, right? What is your conclusion? I'm going to say that we have insufficient evidence that the true population is less than 150. The true population mean is less than 150. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? That is type 1. I'm double checking that real fast. I took some notes here. Okay, so which one involves rejecting the null hypothesis when the null hypothesis is true? Yeah, type 1 error. A researcher decided that instead of using a level of significance of 0.05, he will use a level of significance of 1%, which the following is true. Well, because he's going to be testing for a type 1 error. If he decreases the level of significance, the probability of committing a type 2 error will increase. All right, so if the level of significance equals 5%, what's the probability of committing a type 1 error? Well, that's 5% because you have a 1 in 20 chance of getting it wrong, and that's 5%. So let's submit this. All right, submit quiz. Yes, submit quiz. See what we got here. Oh, we missed one. What could it be? I missed 15. Well, I guess it's a question for the tutor tomorrow because I really don't want to wait. Marco should have been here 15 minutes ago, and he's not. So I'm just going to sign off. Maybe I'll wait 3 more minutes because it's polite to wait 15 minutes, and really he's supposed to be here 12 minutes ago. So that's what I think. So my mom told me, someone's late, you're supposed to wait 15 minutes. Maybe he sent me an email, let me know, hey man, I'm gonna be a little late tonight. Please wait. No. Burp. Excuse me. Let's go back and look at number 15 again. Let's see if I just read it wrong or something. All right. What is the z-score associated with this test? How did I get the z-score wrong but get the p-value correct? Riddle me that. Because I need the correct z-score to arrive at the correct p-value. That's my question. Maybe I'll call up my professor, but I've waited 15 minutes now, so I'm done. See you later. Peace.